Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 13 of a unit current electricity. In today's session we are going to discuss the previous year asked questions that have been asked in the engineering examinations. So let's begin with today's class. But before we proceed with this class, please stop this video if you have not revised the complete syllabus of current electricity. So please revise it first and then come back to the session. If you have did it, well done and all the best. Have your pen and paper and start doing it with me. So let's begin then. The question says that 5 resistors are there which are connected as shown in the figure. If total current is flowing is 0.5 ampere, then the potential difference is required. Potential difference from VA minus VB. So let's have a look then. Equivalent resistance of this network, it's a 666, and these are connected in parallel. So if they are connected in parallel and all are same, it's a 2 ohm. It's an R equivalent would be equals to R by N when they are connected in parallel. And this is 6, this 6, it's a 6 plus 6, 12. So this is 12, this 12 has been connected with the 12 ohm resistance. It's a 12, 12, 6. Yes, and current, it's a 0.5 ampere. So what I can have, it's a V is equals to I into R. 0.5, it's a 1 by 2 multiplied by 2 plus 6. It's an 8 ohm resistance. This is of 4 volt. Yes, we did it. Yes, less than 1 minute question. Even this has been asked in the mains. Yes, so we cannot differentiate that this can be asked in only JEE mains or this can be asked in NEET examinations only. Yes, so that's why we need to attend both the sessions that are whether it is of previous year for the medical or whether it is a previous year for the engineering. So please have a look and let's start doing it. Let's look at the next question. What does it says? Go through it very carefully. It says that copper and carbon wires are connected in series and the combined resistance is kept at 0 degrees Celsius. Assuming the combined resistance does not vary with the temperature, the ratio of the resistance of the carbon and copper wire at 0 degrees Celsius. Yes, very good question. If you remember the thermal properties of matter, on thermal properties of matter, we have derived that length is independent of the temperature if I can have the condition that is of L1 alpha 1 is equals to L2 alpha 2, but at that point I have derived it for the length. Now I know that resistance is directly proportional to the length. Yes, R is equals to rho into L by A. So resistance is directly proportional to the L, and if resistance is directly proportional to the L, you can have this relation that R1 alpha 1 could be equals to R2 alpha 2. So if I write, it's an R1 alpha 1 should be equals to R2 alpha 2. So this can be written as R1 by R2, that could be equals to alpha 2 by alpha 1. Yes, so put up the value. You have been given the alpha. Alpha is the temperature coefficient. So this has been given. Temperature coefficients of carbon is given and temperature coefficients of copper is given. Yes, so this 2 has been given, this 2 has been given, and put up the value and get the answer. Is it clear? Is it? Yes, but do remember this thing. This is very important. Yes, even the 2 or 3 time question has been asked from the thermal properties of matter, and on the same concept a question has been asked with the current electricity as well. So very important question. Yes, please do remember this. It's an important. Ready for the next question? What does it says? It says that a conductor has a non-uniform section as shown in the figure. Great. A steady current is flowing through it. then the drift speed of the electrons. Okay, how could I, as I have been given that my current is same, my current is same, and I am having the relation that is of I is equals to N into E into A into VT. So I have been informed that I is same, and that is the number density which is always same. E is the constant. So I can have a relation that is VD inversely proportional to the cross sectional area. As I can see very clearly that cross sectional area of Q is greater than the cross sectional area of the P. That means if my cross sectional area is higher, my VD should be a lower. That means drift velocity of Q should be less than drift velocity of P. Did it? So from Q to P, or from P to Q, VD at P is greater than VD at Q. So as I move from the P to Q, my cross sectional area is increases. That's why drift speed decreases. Is it clear? Is it clear? Okay. Shall I add something to this? Shall I? Let's have a look. That if in the previous question comments for current density and electric field resistivity, yes, let's work for this only. Yes, if you want, this was the diagram. This was the section P, this was the section Q. Now what do you want? You want the same kind of comments. That means it is increasing or it is decreasing and that kind of stuff only. That from P to Q or from Q to P, what would be the situation? This is what we require. So first what I require a current density. Current density could be written as J is equals to I by A. As I have been provided that current will remain the same, that means the J is inversely proportional to the A. So as I understand, A of Q is greater than A of P. That means J of Q is less than J of P. Did it? Great job. Next, about the electric field, I am having the relation which is of J is equals to sigma into electric field. Yes, sigma, it's a conductivity. This is material dependent property. Sigma is the material dependent property, and if it is a material dependent property, that means it will remain the constant throughout the cross sections. Yes, so if JQ is less than JP, I can have it's an EQ less than EP. The resistivity, again it is a material dependent property, so rho Q at rho P, same way sigma Q equals to sigma P. Yes, because material would be the same, and material would be the same, resistivity and conductivity, these two would be the same. Yes, so can you do this kind of questions? Yes, are you ready for the next question? Let's have a look. What does it say? It says that a current of 16 ampere is made to pass through a conductor in which the number density, what is it? Number density, it's a total number of free electrons in a unit volume which has been given, which is equals to 4 into 10 to the power 28 per meter cube. A current is given and the current is of 16 ampere, and its area of cross section is given, which is of 10 to the power minus of 5 meter square. What do we require? We require the average drift velocity of the electron. Yes, we know that I is equals to N E A into VD, and if I know this, I am having this. It's a VD is equals to I divided by NEA. Yes, the current that is of 16 ampere. The number density it is of 4 into 10 to the power 28. E, it's a charge which is of 1.6 into 10 to the power minus of 19, and cross sectional area which is of 10 to the power minus 5. So if I solve this, I can have a VD that is of 2.5 into 10 to the power minus of 4 meter per second. Is it clear? Is it? Is it clear? Great. Ready for the next question? Ready? Let's have a look then. What is question is about? Let's have a look. It says that in the circuits shown in figure, the ammeter, that means the current measuring device that we have discussed, 5 ampere current, while the voltmeter shows 250 volt. It's a voltage measurement device, and the internal resistance of the voltmeter is 2500 ohm. Internal resistance of voltmeter is 2500. Then the value of the R. Yes. So how could you do this? What I understand is that this current is of 5 ampere, and this voltmeter shows a 250 volt, and again the internal resistance of voltmeter, which can be represented over here, is 2500 ohm. I need to calculate the value of this R. I need to calculate this. So how could you do this? How can I? So what I understand is that this resistance R and this resistance which is of 2500, these two are connected in parallel with each other, and voltage or potential drop across them is 250 volt. So let's just find it out. R equivalent, which should be R into small r, it's an internal resistance, divide by R plus R. Yes, I hope these things are clear. Is it? So this could be written as it's a 2500 multiplied by R divided by 2500 plus R. This is the R equivalent. Yes, yes, this is the R equivalent. And what you required, it's a V is equals to I multiplied by R equivalent. The V, it is of 250 voltage. V, that is of 250 voltage. Current that is flowing through the circuit is 5 ampere multiplied by R equivalent. So this R equivalent, it's a 250 divided by 5, that is of equals 250 ohm. And now this 50 can be equated, this R equivalent could be written as 2500 multiplied by R divided by 2500 plus R, that could be equals to 50. Now solve this and get the value of R. Is it clear? Is it? Is it? Great. Ready for the next question? Yes, this is very important question. Very important. Yes. Let's have a look to this question. What does it say? It says a battery of EMF E and internal resistance R is connected to a resistors of resistance R1, and Q joule of heat is produced in a certain time t. When the same battery is connected to another resistor of resistance R2, the same quantity, it means the Q joule of heat, is produced in the same time t. Value of R is, take a time of 10 seconds and again read it. What does it say? Take a time of 10 seconds, 20 seconds. Okay, do you understand what does it mean? Do you? It says that it is the battery having an internal resistance R is connected to a resistance first connected with the R1, and in the next situation connected with the R2. This is E and R. As it has been connected through R1 and R2, a same amount of heat, a Q joule of heat, is produced in a certain time of t. Now when the same battery is connected to this resistor, that is the resistor R2, then the value of R, that means amount of heat that is produced here, it's a Q, could be written as I square RT. This Q would remain the same for both the cases. This is the first case and this is the second case. This Q would be the same. So how could I do this? Let's have a look. I can have it set Q1 is equals to I. Thus I can be written as E divided by R plus R1, and in second case that is the I is equals to E divided by R plus R2. So this is equals to Q1 is equals to E divided by R plus R1 whole square multiplied by R1t, and this Q2 is equals to E divided by R plus R2 whole square into R2 into T. So if I equate this, because I know that Q1 equals to Q2 according to the data, Q1 equals to Q2. So the internal resistance would be equals to root of R1 into R2. Please do remember this, because you have been asked questions, based on directly from this. Yes, but do you understand the concept and logic behind it? Do you? So can you do this kind of question? Let's have one. That in the previous question, if internal resistance of cell is 12 ohm and it produces 80 joule of heat if connected with 16 ohm of resistor, find another resistor with which it should be connected so that it can produce heat of 80 joule. This is what we require. Yes, it says that go through the data again and again, go through it once. What it says that in the previous question, if the internal resistance of the cell is 12 ohm and it produces 80 joule of heat, if connected with a 16 ohm of resistance, then find the another resistance with which it should be connected so that it can produce a heat of 80 joule. That means this heat should remain the same. So R should be equals to root of R1 into R2, and this is 12 ohm. So let's just square this. It's a 144, that is equals to 16 multiplied by R2. So R2 can be equals to 9 ohm. Yes, so even if the same cell is used, and that cell has been connected with the 9 ohm resistance, it will produce the same amount of heat as it has been produced with the 12 ohm resistance, with the 16 ohm resistance, sorry. Is it clear? Is it? Yes, very good question. Please remember this. And let's work for the next question. Yes, let's have a look. It says a battery of EMF 2.1 volt and internal resistance 0.05 ohm is shunted. What does it mean? Shunted, that means, yes, we have discussed in the previous year asked questions of the medical session. Yes, when and when they use the word shunted, it means they are connected in parallel. Yes, shunted for 5 seconds by a wire of constant resistance, that is of 0.02 ohm, mass 1 gram and specific heat of zero point 0.1 calorie per gram per degree Celsius. The rise in the temperature of the wire. Yes. So the concept is the heat produced according to the Joule's law. It is I square R delta T, and rise in temperature of the wire could be written as Q is equals to MC delta T. Yes, this is again, if you have been taken this as a misunderstood, that this is I square R into T. That means for the time the current is flowing and the heat is produced, you need to find out the rise in the temperature of the wire. So let's just equate this. What is I? Let's have a look. This is the battery. This is of 2.1 volt and this has been connected with the internal resistance of 0.05 ohm, and it is shunted for 5 seconds by a wire of constant resistance. It is shunted by a wire of constant resistance which is of 0.02 ohm. So the current could be written as it is E divided by R plus R. So let's just put up the value and try to get it done. This is the I square RT. I can be written as E divided by R plus R whole square multiplied by R into T. That could be written as M into S into delta T. Yes, S is the specific heat capacity. It is given as a 0.1 calorie, but this has been given in calorie, and everything else is being given in the SI unit. So you need to convert this calorie to joule, and we know that 1 calorie is equals to 4.186 joule. So try to get it done and you will find the answer, that is of 214 degrees Celsius. Yes, this would be the answer if you calculate it. Is it clear? Is it any doubts? Anything? No? Ready for the next question? Yes. Let's have a look. Very easy question. Do it quickly. What does it say? It says current versus voltage graph for a given metallic wire at two different temperatures T1 and T2 is shown in the figure. The temperature T1 and T2 are related as. First, have a look. This is I, this is V. So if I take a slope, it would be I by V, and I by V, that means it's a V 1 by R. This is the 1 by resistance. This is equals to V is equals to IR. First thing, is it clear? Is it clear? Great. Next thing is for metal resistance increases if temperature increases. So if I understood that this is the theta 1, this is the theta 2, then slope of T2 temperature wire is greater than slope of this T1 temperature wire, and as its slope is higher, its resistance will be lower. It's a RT2. It's a RT2 would be less than RT1. Yes. So what you understand? It's a T2 must be less than T1. Yes. Even you can got this approach as well. Yes. even this can be the relation where you can understood that V is equals to IR, and from this you can have the relation that is the temperature dependency of the resistance. It's an RT is equals to R naught into bracket 1 plus alpha T. So from here you can easily get it done. Yes, let me do certain modification to this. That, let's suppose this is V, this is I, this is T1, this is T2. It's a graph for metallic conductors is shown in figure. Yes, comment on their temperatures. So what I understand is that slope of this graph, it's a V by R, which would be equals to R. It's a voltage versus current, and the ratio of this slope of this graph would be the resistance. If I understand this slope very carefully, it's a theta 1, it's a theta 2, and slope of theta 2, and while I say theta 2, I'm talking about the slope of T2 is greater than slope of T1. So as slope is higher, the resistance would be the higher. Resistance of T2 would be greater than resistance of T1. And if their resistance are higher, that temperature would be higher. This is T2 is greater than T1. Is it clear? Is it? Are you sure? Great. Let's work for the next question. Did you enjoy this? Do you? Yes, this is just like a practice sessions. Yes, and it gives us the feelings of the examination hall that there are questions that is coming down and down, down and down, down and down, and we need to solve it within certain amount of time. So let's continue this practice. Let's look at this question. A flashlight lamp is marked as 3.5 volt and 0.28 ampere. The filament temperature is 425 degrees Celsius, and the filament resistance at 0 degrees Celsius is 4 ohm. Then the temperature coefficient of the resistance of the material of the filament is, yes. So first thing is, what is the resistance of this wire? The given rated voltage and current is 3.5 volt and 0.28 ampere. So if I calculate the resistance, it is the R is equals to V by I, which can be related as it's a 3.5 divided by 0.28, and if it is 3.5 divided by 0.28, it's a 12.5 ohm. Now resistance at 0 degrees Celsius, it is RT equals to 4 ohm. That has been given. What I need to find out, the filament temperature is 425 degrees Celsius, and I need to find out the temperature coefficient. It's an alpha. How could I do this? Let's have a look. We can have this relation, that is alpha is equals to R2 minus R1 divided by R1 into delta T. If you don't know this, then I can have this relation, that is R2 is equals to R1 into bracket 1 plus alpha into delta T. So if I solve this, it's R2 by R1, that could be written as 1 plus alpha into delta T. That could be written as R2 by R1 minus of 1 equals to alpha into delta T. So this is R2 minus of R1 divided by R1, that is equals to alpha into delta T. So Thus alpha is equals to R2 minus R1 divided by R1 into delta T. So now the resistance, it's a 12.5 ohm. At 0 degree Celsius it is at 4 divided by 4 into bracket delta T, a temperature variation. The temperature variation is, it's a given, and that can be written as 14.25. And if I solve this, I can have the value of alpha. Yes, understand the concept behind this? Yes, even we have derived this relation that alpha is equals to 1 by R multiplied by dr by dt. Yes, if you don't know this, if you don't remember this, please revise the current temperature dependency of resistance and resistivity. At in that session you will find all these theories. Yes, please revise it. Now let's look for the next question. It says a projector lamp can be used for a maximum voltage of 60 volt. Its resistance is 20 ohm and the series resistance required to operate the lamp from a 75 volt supply. So what you need to do, a projector lamp can be used at the 60 volt and its resistance is 60 ohm. So if I find out the current through this, it's a 60 by 20. Now what I am supposed to do is I am going to add certain resistance. I am going to add series resistance so that it can be operated with the 75 volt, but current would remain the same. So now new current will be equals to 75 divided by 20 ohm plus R, and this 2 should be the same, because if bulb wants to be operating, that is the maximum current that can be flow through the circuit. So it's an I is equals to I dash. Let's just put up the value. It's a 60 by 20, that should be equals to 75 divided by R plus 20. It's a 23 is a 60, and so if I solve this, it's a 3R plus 60 is equals to 75, and thus R is equals to 5 ohm. Very easy question, very easy, but highly conceptual, that I must understand that this two should be the equal. If I don't know this, probably I am not able to solve this. Yes, is it clear? Is it clear? Great. Ready for the next question? Are you ready? Let's have a look. Again, very easy question. It says that a teacher asks the students to connect n cells, each of EMF E, in series to get a total EMF of n into E. While connecting, the students by mistake reverse the polarity of n cells, the total EMF of the resulting combination. Yes, we understand that this is equals to n minus of m into E, while n was total number of cells, m, it's a wrongly connected cells. This is wrongly connected cells. So this is E, which is equals to n minus 2m. Sorry, my mistake. It's a E which is equals to, this is E is equals to n minus of 2m into E. Now for me, it's a total number of cells are the n, so I have written it, and by mistake I have connected the reverse the polarity of small n cells. It's a n minus 2n into E. So that's it, you did it. Great job. Yes, will you be able to solve this kind of questions? Will you? Are you sure? Let's have a look to the next question. What it is about, it says that two wires A and B of same material, that means their resistivity is equal, that is the rho A is equals to rho B, having their lengths in the ratio of 6:1. L1 is to L2, it's a 6:1. Connected in series, that means current is equal. The potential difference across the wires are 3 volt and 2 volt respectively. Okay. If RA and RB is the radius of A and B respectively, then I need to find out the RB is to RA. So how could I get it? What I understand is V is equals to I into R, and as I have been given that it is they are connected in series, so I would be cancelled out. So R is equals to rho into L by A. This is equals to I into rho into L by A, and if I put up the value, I would be the same. It's a rho L divided by pi R square. So they have provided that I would remain the same, and material is same, that means the density is same. So that means they can have, it's a V directly proportional to the L by R square, or from here it's an R that is directly proportional to the under root of L by V. Is it clear? Yes. So let's just put up the value. It's an RB is to RA, that is equals to LB by LA multiplied by VA by VB. LB by LA, it's given the data, it's a 1 is to 6, yes, and VA is to VB, it's a 3 by 2. So this is 3 2s are 6, 3 2s are 6, it's a 1 by 4, and if I keep it this out of the square root, it is a 1 by 2. This should be the answer. Is it clear? Is it? Any doubts on this? No? Great. Ready for the next question? Are you ready? Let's have a look to this question. What does it say? It says that the temperature coefficient of resistivity of a material is this per Kelvin. When the temperature of the material is increased by 50 degrees Celsius, the resistivity increases by 2 into 10 to the power minus of 8 ohm per meter. The initial resistivity of the material in ohm meter. Yes. So what I can have is change in resistivity is equals to initial resistivity into alpha into delta T. Yes. Change is approximately 2 into 10 to the power minus 8. Yes. Change is, because it says the resistivity increases by 2 into 10 to the power minus 8. Initial resistivity, I don't know, I'm working for it only. And delta T, it's 17 into 10 to the power minus of 4 multiplied by 50. Yes, it has been changed by 50 degrees Celsius. If I solve this, I can have the value of initial resistivity. I hope these things are clear. Is it clear? Is it? Are you sure? Great. Even this can be done. It's an rho 2 is equals to rho 1 into bracket 1 plus alpha into delta T. Yes, this is the resistivity at T temperature, and this is the resistivity at 0 degrees Celsius. Even this can be done, but this is the better approach. I hope these things are clear. Is it clear? Ready for the next question? Very important question. Yes. And this has been asked for the 3 times. Yes. In the one situation it has been asked back to back years. Yes. So let's look at this. 2 cells with same EMF E and different internal resistance R1 and R2 are connected in series to an external resistance R. So let's have a situation. It's an E and its internal resistance, let's say R1, and the another cell, it's the same EMF but its internal resistance is different. So this is R2 connected is series to an external resistance that is of R. Yes, the value of R, so that the potential difference across the first cell is to be 0. That means V1. This is the potential difference across first cell. This is to be 0. That is what requirement is. So let's just calculate the electric current flowing through this network. The current could be written as this is E Even this is E. So this could be written as I is equals to 2E divided by external resistance R plus R1 plus R2. Now let's write it down, the potential drop across this. It is a V1 is equals to E minus of IR1. This is V1 is equals to E minus IR1. And what I want that V1 equals to 0. So if I want this, so let's put it up and try to get it done. It's a V1 is equals to I into R1. I want this should be a 0. This is equals to E minus of I. It's a 2E divided by R plus R1 plus R2 multiplied by R1. So let's just solve it. It's a E that should be is equals to 2E R1 divided by R plus R1 plus R2. This 2 has gone, and the term that remain is the R plus R1 plus R2. That should be is equals to 2R1. So what I can have, it's a R is equals to 2R1 minus of R1 minus of R2. So this 2R1 minus of R1 can be written as R1 minus of R2. This is equals to R. And this would be the answer. Yes. Let's look at next question and do it quickly. This question we have done it in the previous example as well. So let's look at this. It says in potentiometer experiment, a cell of EMF 1.5 volt connected in the secondary circuit gave a balancing length of 165 centimeter of the wire. Now, if the resistance of 5 ohm is connected parallel to the cell, the balancing length of the wire, is 150 centimeter. Calculate the internal resistance of the cell. Yes, so this L1, it is the current when it is the balancing length when no current is flowing, which is a 165 centimeter, and the 150 centimeter, it is the case when current is flowing through the circuit. So this is L1, this is L2, and what do you need to find out? You need to find out the internal resistance. So let's just put up the value and get it done. That is the R is equals to L1 minus L2 divided by L2 into R. So that should be is equals to L1, it's a 165, L2 it's a 150 divided by 150, and if I solve this, it's an internal resistance R is equals to half of the ohm. It's a 0.5 ohm. Is it clear? Yes. So please do remember this formula. And next, it is the three equal resistance, each of 3 ohm are in series and connected to a cell of internal resistance 1 ohm. 3 equal resistance each of 3 ohm are in series and connected to a cell of internal resistance 1 ohm. If this resistance are in parallel and connected to the same cell, then the ratio of the respective electric currents in the two cases. Yes, the situation 3 equal resistance each of 3 ohm connected to a cell. This is E, this is its R, which is of 1 ohm, and if they are connected in series, it would be a 9 ohm. 3 plus 3 plus 3. Next, if they have been connected in parallel, the situation should be, this is internal resistance, and 3 comma 3 comma 3, it's a 1 ohm. So this is the case when they are connected in series, this is the case when they are connected in parallel. So in first case, E1 could be written as, let's say certain current I1 would be flowing through this and I2 would be flowing through this. So E1 is equals to I1 into bracket 9 plus 1, it's a 10 ohm, and E2 is equals to I2 into 1 plus 1, 2. Yes, as I know that this is the same cell, so E1 and E2, this 2 would be the same, and if this 2 would be the same, I1 is to I2, which is equals to 2 by 10, and 2 by 10, that means equals to 1 by 5. That's it. You did it. Great job. Well done. Does it clear? Does it? Ready for the next question? Ready? Yes, we are on the completion of the session. So have patience and keep doing the questions. Let's look at this question. It says an ideal battery of EMF 2 volt and a series resistance R are connected in the primary circuit of a potentiometer wire of length 1 meter and resistance 5 ohm. So let's just have this. It says an ideal battery, it's a 2 volt and the resistance R are connected in the primary circuit of a potentiometer wire. Let's say this is the potentiometer wire. This is point A, this is point B, and this is of 1 ohm length and 5 ohm resistance. Okay. The value of R to give a potential difference of 5 millivolt across the 10 centimeter of potentiometer. So how can you do this? First, what I understand it, let's just calculate the value of the current that can be passed through this. Yes, that is the I is equals to 2 divided by resistance R plus 5 ohm. So this is the current that is going to pass, going to pass through the circuit. Now what I want is I required a potential difference of 5 millivolt across the 10 centimeter of potentiometer. Yes. So what I understand is that this is the 1 meter of wire. This is a wire of 1 meter. That means the if 1 meter stands for 100 centimeter and it is having a resistance of 5. So if my wire it is of 10 centimeter, what would be its resistance? What would be the value of a resistance? How could I get it done? It's a 10 into 5, that should be is equals to x into 100. Yes, so x could be equals to 50 by 100. So this is half ohm. This is the half ohm. Yes, so each 10 centimeter is covering the half of the ohm of the resistance. Why I do this? Let's have a look. V is equals to I into R. What do I require as an voltage? I require a 5 millivolt. What is the current that is moving or that is flowing through the circuit? It's a V is equals to, that is the V is equals to I. The current is 2 divided by R plus 5 multiplied by the resistance, what is it? The resistance of the wire. Yes, it's a 2 divided by R plus 5 multiplied by the resistance, it's a R by L multiplied by capital L. So this is equals to 2 divided by R plus 5. The total resistance of this wire, it is of 5 ohm. The total length is 1 multiplied by, you are going to use the length that is of 10 centimeters. So this is 10 divided by 100. This is equals to 5 into 10 to the power minus of 3. I hope these things are clear. Is it clear? Is it? Great. So this is 2 5s are 10 and 10 10s are 100. Yes. So this could be written as 5 into 10 to the power minus 3 is equals to 1 divided by R plus 5. Yes. Just solve for the value of R. This would be your answer. I hope these things are clear. Is it? Is it clear? Great. Now let's move to the next and the final question of this session. What does it says? It says if an electron revolves in the path of a circle of radius which is of 0.5 into 10 to the power minus of 10 meter at a frequency of 5 into 10 to the power 15 cycles per second. Yes. Then the electric current in the circle is yes. So basically this is the case of the mechanical current, where we can say it's an I is equals to Q by T, or I can write like this, it's a Q into F. The charge of electron that is given, which is a 1.6 into 10 to the power minus of 19 coulomb multiplied by frequency. It's a 5 into 10 to the power 15. So this is 1.6 multiplied by 5. 1.6 multiplied by 5, it's an 8 multiplied by 10 to the power minus 19 into 10 to the power plus 15. So this is 8 into 10 to the power minus of 4 ampere, or we can say it's a 0.8 milliampere. Yes, is it clear? Is it? Great. So let's just winding up the session over here. Yes, this is the all about the previous year asked questions that have been asked in the engineering examinations. Yes, so this is all about the current electricity. Now we have done electrostates, that was the first and second unit of class 12, and this is the current electricity while charges are in motion. I hope those things are clear. Yes, from the next session, from the next class, we are going to learn the next unit. Yes, and it covers magnetism. Yes, so this is the first session of your class 12 studies. Please revise it very carefully, because this 3 units as in combined have an capability to deliver 2 to 3 questions in your competitive examinations for sure. So please revise it carefully. Thank you, have a good day, take care, bye bye.